tutorial, I will solve the focused questions and explain the answer key. So, question 1, define a spontaneous process and explain how thermodynamics is involved. As you all know that a spontaneous process is a reaction that occurs without any outside intervention. So it doesn't need an energy source like a battery, certain kind of conditions. So it's just a spontaneous system that can, a reaction that can happen by itself. Now, spontaneity is related to the Gibbs free energy. Symbol is delta G. And for a process to be spontaneous, delta G should be negative, which means there is free energy available to do the reaction. And this delta G is driven by two factors, the entropy, delta S, and the enthalpy, delta H. So these two will decide whether a system is going to be spontaneous or not. Now, another question, which of the following best defines a spontaneous process? So a reaction that occurs instantly, not necessarily. I can have a spontaneous process that is slow. So it could be fast, it could be slow, but it's still spontaneous. Like for example, rusting of iron can take months, and fireworks, it happens instantly, within seconds. A reaction that requires continuous energy input, that is not a spontaneous. This is non-spontaneous. The definition is a reaction that occurs without any outside intervention. D is wrong because it could be exothermic and it could be endothermic, the spontaneous process. Next, what does the spontaneity of a reaction indicate? So it indicates that this reaction can happen. That's what it indicates. It doesn't mean that it's fast, but it can happen. So it will always happen quickly? No, not necessarily. Requires a catalyst? Not really. It can happen with or without a catalyst. It must involve an increase in entropy? No. Even if I have entropy decreasing, certain kind of temperatures will make the reaction spontaneous. So spontaneity indicates that thermodynamically this reaction can happen, favorable. Products are favored thermodynamically. That's what it means. Now, explain why the spontaneity of a reaction does not indicate its speed, because it's simply not related to speed. Speed is related to kinetics, reaction kinetics that you took in grade 11. So a spontaneity will tell you whether there is free energy available to drive the reaction to do work or not. So being spontaneous, it means yes, there is free energy available to drive the reaction. So if delta G is positive, it means we need this much of energy to start to make it happen. Will a reaction that is thermodynamically favored be a fast reaction? Yes, it can be a fast reaction and it can be a slow reaction. Okay, so yes, and it can also be slow. Regarding the written answers, you can see them in the written answer key that I have posted for you on Teams. Next, explain how a catalyst affects spontaneity. So a catalyst, the main role of a catalyst is to speed up a reaction. So if a reaction is non-spontaneous with a catalyst, nothing's gonna change. It will remain non-spontaneous. And if a reaction is spontaneous with a catalyst, nothing will change. It's not gonna do any changes to it, because a catalyst affects the rate, the speed of the reaction, and not spontaneity. Complete the sentences about exothermic and endothermic reactions. Now, since this is coming in the focused questions, so I am expecting questions about that. So let's start. Exothermic is a reaction that releases energy to the surroundings, to the surroundings. Okay? And for an exothermic reaction, the enthalpy is always negative. Okay, now here below in the table, I'm gonna explain it. What happens? Here's the exothermic. We start with reactants having high potential energy. This is the level of potential energy, and this is the progress with time. So if the potential energy is high, it means they are less stable. So what happens is that the bond breaks in order for new bonds to form. Now those bonds, when they break, they absorb energy, and the new bonds to form, they release energy. Now, being an exothermic process, it means that the energy released is much more than the energy absorbed, which means that the bonds forming the products are stronger than the bonds that were in the reactants. And it also means that when energy is released, the products are more stable than the reactants, simply, here the products, simply because their energy, their potential energy, is less than the one of the reactants. Okay, so that's for the exothermic. So here in the exothermic, the products, they have lower enthalpy than the reactants. Look at it, lower. The reactants, they have higher enthalpy. The products, they have stronger bonds. Yes, because they released more energy than what it was absorbed. So this is the amount of energy absorbed. This is the amount of energy released. So to break the bond, we absorbed this much of energy, but to form the bonds, this was released. So definitely the products have stronger bonds than the reactants. Now, products are more stable, yes, again, because their potential energy is lower than that of reactants. Okay, so an energy is released, delta H is negative, and that's it. Yeah. Now for the endothermic process is a process that absorbs energy from the surroundings. So it takes the energy from the surroundings, and usually for an endothermic process, the enthalpy is positive. Now let me draw the graph. So here's the potential energy level, and this is the progress of the reaction with time. So for an endothermic reaction, usually reactants, they are having lower energy and they are more stable. They absorb, and to form the products will be having a higher level of potential energy. Yani products are less stable. Here, products, you see this level is higher than this level. When the potential energy is higher, it means that it is less stable. So that's why we say products are less stable than reactants. Type, what caused this? Reactants, to break their bonds, absorbed this much of energy. Good. Now the products, to form their bonds, they released this much of energy. Now, first of all, this means that to form the bonds, we don't need much energy. So the products, they have weaker bonds than the reactants. Then, another thing, the reactants are a lot stable. They absorbed so much energy to make them unstable and break their bonds. And the products, to form the bonds, they released energy. But this energy released is not more than the energy absorbed. Therefore, the enthalpy of an endothermic system will be positive. Okay? And the products, they will have higher potential energy than the reactants. See, higher potential energy than the reactants, which makes them less stable. So my expectations is to have a question like this in the exam. So please give it good time, this question. Which of these processes results in entropy being positive. So many factors will increase entropy. Check that in the summary notes. Now let's look at the first example. In here or in here, always examine the physical states. Gas, gas, gas. So this cannot tell me anything because they are all gas. Now, in this one, solid and gas, and the product is only gas. So this means that the entropy, as a first look to this one, decreased because the entropy of solid is less than the entropy of gases. One. Second, I had two reactants substances. They were combined to form only one. It means also that the entropy decreased. I'm going from two substances for one substance, so entropy is less. Looking at this one, we count the mole. 2 moles contributed to the formation of 3 moles. So the amount of molecules of gas is more. This is an increase in the entropy. So more distribution. So this is the answer. So which process result in an entropy increase? This one, not this one. Now comparing these two, solid to gas, yes, that's an increase in entropy. Liquid to solid, that's a decrease in entropy. Now, another question. Okay, which substance? Choose the substance that has higher entropy value and justify. Liquid or gas? Of course, the gas. The gas will have more randomness. Particles will move. Particles in a gas are moving freely. Just describe the motion of gas. Are moving freely with more space between them. Their volume is larger, with more randomness, with more randomness. And if I have volume, if I want to compare, the volume of a gas is much larger than the volume of a liquid. So that's why they will have more motional freedom and higher entropy. Now, CO2 gas or O2 gas? Okay, I have two substances that are gas, so I'll choose for the more complex, the one with more molar mass, the one with more atoms in it. Like here I have 3 atoms, 1 carbon, 2 oxygen, whereas O2 I only have 2 atoms of oxygen. So the more complex the molecule, the more vibration the bonds will have, the more possible motion the bonds will have. So we say molecule complexity will increase the entropy. Why? Because this complexity means that there are more motion and vibrations within this molecule. Identify 4 processes where entropy always increase. In the answer key, they mentioned melting of ice. Yes, because this is going from solid to gas, to liquid. You can say the melting of anything. Melting of, for example, iron, melting of metal, melting of a salt, whatever melting that comes on your mind, you can put, not necessarily only ice, any melting process. 1. 2. Any evaporation process. So in the answer key, we wrote evaporation of water, but I can tell you evaporation of a solvent, ethanol, evaporation of chloroform, carbon tetrachloride, any substance that you have on your head, you can say evaporation of that substance because it's going from liquid to gas. 3. Any mixing of gases, mixing of salts, mixing of gases together, they will like have mixture of particles. Any mixing you can have as an example, it will result in the increase of entropy. Dissolution of salts in water. whenever I have a solid solute, like NaCl solid, and I am dissolving it, I place it, I throw it in water, and I let it dissolve. It becomes aqueous. This solution of salts in water. What you cannot say, this solution of gas in water. The solution of gas solute will not result in an increase in entropy. Okay, so if I have O2 gas to O2 aqueous, that's a decrease in entropy and not an increase. Next, you might get multiple choice questions stating the law of thermodynamics, the laws of thermodynamics. So the second law will tell you that the entropy of the universe is always increasing. It's an non-stop increase. So S is always increasing for a spontaneous process. And the third law of thermodynamics will tell you that the entropy of a perfect crystal, which is hypothetically not possible, but this is it, hypothetically speaking, the entropy of a perfect crystal is 0. Write the relationship of entropy of surroundings and enthalpy of system of reaction with units that predict the changes, then predict the changes in the entropy of surrounding for exothermic and endothermic. So here, this is a formula that we took in class, and I also, in the summary notes, I left this formula for you. Be careful, we're talking about entropy of surrounding, not system. It is equal to negative enthalpy of system of the reaction over the temperature. Now, the entropy of the system can be negative if it's exothermic and can be positive if it is endothermic. So, if we're dealing with an endothermic system, the entropy of the surrounding will be equal. There's a negative in the formula. Entropy of the system is already positive. Temperature is already positive. So the entropy of the surrounding will be negative. It means it will decrease. If I have an exothermic reaction, the entropy of the surrounding will be negative because I have a negative in the formula. Now, enthalpy of an exothermic system is already negative, and the temperature is positive, always positive. So minus and minus, and it will be positive. It means that the entropy of the surrounding will increase for every exothermic reaction. Now, one more thing, please be aware of the units. Joule per Kelvin. This one, kilojoules, and this one in Kelvin. So we always have to do our conversion from kilojoule to joule or joule to kilojoule. Explain the value of delta G mathematically under different conditions of positive and negative. Okay, let me just revise this again with you, because you will be given equation and you have to examine the signs of delta H and delta S in order to know when delta G is positive or negative. So the way I explained it in class, I told you, you think about delta S and delta H. I'm recording. Delta S and delta H. So if both of them are negative, it means that this process is spontaneous only when temperature is low. At low temperatures. Okay? Now, for both of them, if both of them are positive, this system is spontaneous only at high temperature. So remember, minus will remind me with something negative, less than 0, so you will say spontaneous at low T. Positive, remind me with something high, so you will say spontaneous at high temperature. Now, these two you need to memorize. When enthalpy is negative and entropy is positive, this one is forever spontaneous. Spontaneous at any condition, at any temperature. And when the reaction is endothermic and decreasing entropy, this will never ever be spontaneous. So we say non-spontaneous at any temperature. Okay, so once you have a question related to the signs of delta H and delta S, please put that table on the side and start answering the questions. Here's the formula: delta G equal delta H minus T delta S. T is always positive. Okay, and these two values are multiplied. Now, next. Delta G has a negative value. Good. Spontaneous. Spontaneous. We also studied that K will be larger than 1. And later on, when we started the galvanic cells, E cell is positive. These are all related. The standard entropy of a reaction is calculated. The standard entropy. Okay, yani delta S reaction. This is a formula that you don't have to worry about. It's given in the formula sheet. It's the sum of the entropy of products, and if every product having a stoichiometric coefficient, you will multiply it by that number, minus the sum of the entropy of reactants. So be careful. Yani I'm gonna explain. You look at this one. See those two, the number 2, not to ignore. So here, let's solve this question. They want to find the entropy of this given reaction. First, here are the products, and here the reactants. You see the product is multiplied by 2. So you go for the entropy of H2O and you multiply it by 2. So it's going to be 69.9 multiplied by 2. Use brackets because I need you to avoid mistakes in the signs, and use those brackets on your calculator. Now, minus, because the formula says minus. Minus what? Minus the sum of entropies of reactants. Here's the O2. Here's the O2, which is 205.2. Put it in brackets. Plus, and here have those parentheses. Plus, twice the one of hydrogen. So this value times 2. So 130.7 times 2. That's it. And you plug it into your calculator. You are going to get an answer of negative 326.8. The unit is a joule per Kelvin. Per Kelvin. Yes. In the answer key, they wrote a joule per mole. Now I'm just paying attention to it. It's joule per Kelvin. Next, use the table below to answer the questions. Thermodynamic quantities for selected substances. Here are the delta H's, the delta G's, and the entropies. Okay, so in this question, they want the delta S. The delta S for this reaction. Okay, so in order to find the delta S of this reaction, here is delta S. How did delta S? So I have C2H4 gas. I have this value, 219.4 minus, open brackets, hydrogen and C2H2. Hydrogen and plus C2H2, 200.8. And the rest you'll do it. So the answer would be, look, here the unit of Entropy is joule per Kelvin mole. You didn't multiply by any number here. So your answer will be 112.0, also joule per Kelvin mole. Do not change the unit. Next, calculate delta G for the reaction. Delta H is this much, negative, and delta S is positive. Let's think again. Always have your expectations, yani think before solving. Delta H is negative, delta S is positive. This reaction is always favored, is always spontaneous. I just mentioned this here. So negative, positive, spontaneous at any temperature. Yani you should expect after solving to obtain a negative value for delta G. Okay, so delta G is equal to delta H minus T delta S. T given. Delta H is here. Delta S is here. Be careful. Delta S is in joule. We always get delta G in kilojoule per mole. So this one needs to be divided by 1000. So let's substitute. Delta H is minus 483.6. Use parentheses because you will avoid mistakes in the calculations. Minus. This minus, I wrote it here. Temperature 298. Put it in brackets. And delta S is 163.2 in joule. I want it in kilojoule to match with the unit of delta G and with the unit of delta H. So you will divide it by 1000. And that's it. You plug it into your calculator, you get minus 532.2 kilojoule per mole. Okay? So, as expected, we expected delta G to be negative, and here it is negative. Be careful to the delta S. Sometimes, to make the question easy, they might give it to you in kilojoule. Be careful. If it's in kilojoule, no need to divide. If it's in joules, we divide. Next. Ozone in the lower atmosphere is a pollutant that can form by the following, etc. Okay, use the standard free energies of formation to determine delta G. Okay, delta G of formation. I have products minus reactants. Here we go. The first product is O3. You multiply it by 4. The second product is H2O. You multiply it by 2. The third product is CO2. So all these values to add. So 163.2 times 4 plus 2 times 228.6 plus negative 394.4. Please always use parentheses. Now, all of this minus the reactants. Who are the reactants? I have O2, 8. 0 times 8. Even if it's 0, you write it. You have to write it. It has a mark for substitution. So 8, let me write 8 in a nice proper way. So it is 8 multiplied by 0 plus CH4, which is here, negative 50.5, and that's it. Okay? Now you plug it as it is in your calculator, you will get negative 148.3. Now, here we go, the unit. This is kilojoule per mole, but what did you do here? You multiplied by 8 mole, and here by 2 mole, and here by 4 mole. So, this will be per kilojoule, just kilojoule. Okay? Now, next, differentiate between delta G, 1 second, differentiate between delta G 0 standard and delta G non-standard. Delta G refers to the free energy in standard conditions. Standard conditions. This is given in the formula sheet. The formula of this one is given, which is equal to minus RT ln K. Delta G without a zero is the Gibbs free energy at non-standard conditions. And it is equal to delta G non-standard is equal to delta G standard plus, you flip that sign, plus RT ln, and not anymore K because K is at standard. We call it Q. Okay, so tabulate the relationship between delta G and delta G standard and the mass action ratio, yani Q. Okay, now here we go. If Q is equal to 1, we are at standard conditions. Delta G standard equal delta G. So there is no non-standard conditions. Now, if Q is equal to K, the constant, the equilibrium constant pressure of gases, if they are equal, it means that we are at standard conditions, delta G equal minus RT ln K, and you find K. Use the equilibrium formula. This is under equilibrium conditions. Okay, when we say under standard conditions, here we say under equilibrium conditions. Now, under non-standard conditions, delta G would be delta G standard plus RT ln K. Okay, so I gave a question like this in the exam, in the quiz that you had, and I didn't find in the focused question as a question to solve like this, but in the practice questions and the additional questions, I left a question for you to practice it. Okay, I don't know if they're just going to ask about the formula or ask you to use the formula and do calculations. So if you need to use the formula and do calculations, I left a question for you in the practice sheet, in the additional questions. Please check it. Okay? And now, moving on. Use the swing curves to describe the spontaneity of a reaction based on the sign of standard free energy and the value of equilibrium constant. Okay, now, they are stressing a lot on this curve, so maybe it's coming. Look at this one. You see this level of Gibbs free energy of reactant, and this is the level of Gibbs free energy of product. Look at it. It looks like the exothermic enthalpy. Start from here. This is higher, product is lower, delta G is 0. خلاص. Stop thinking about the graph. If it's annoying you, just explain what delta G means. Delta G 0, negative. Okay, this reaction is spontaneous. If this reaction is spontaneous, then K is more than 1. If K is more than 1, products are favored. Finished. You see the curve shifted to the right. Okay, and K is above 1. Now, another graph. Look at the level of G of reactant. Look at the level of the G of the products. Reactant are lower, products are higher. This looks like an endothermic reaction. This one looks like, it looks like that graph, okay? So, oops, like that. So, here, when I have a curve like this, directly delta G is positive. So, we are dealing with a non-spontaneous reaction. We are dealing with a K less than 1. And you will see the curve shifted to the left. Okay? So that's it. Now, don't complicate the questions. Probably they will give you a graph and they will tell you to extract information from that graph, just like this one. Okay, so always start with the level of G product and G reactant. G reactant, G product. Who's higher, who's lower? Identify the sign of delta G and then explain what you know. Now, balancing. Three questions of balancing are coming in the focused questions. It means there is a question coming in the exam. Maybe the same equation, maybe not. I left a video tutorial for you to learn how to balance. Please, please, please repeat it as much as possible. I'm not sure if they're gonna give the same or different. So here we go, step by step. This is the equation. You split it into two half equation. NO3 minus giving NO2. First check, 1N, 1N, N is balanced. 3O, 2O. You add H2O to the side that has less oxygen. Now I have two hydrogens, so you balance H by adding H plus on the side that needs H. Now count the charge, 1 minus, 2 plus. 1 minus 2 plus means 1 plus in total. Here, no charge, 0. Where is the higher side? Here is the higher side. So you add electrons on the higher side to lower it to be balanced with the other side. So plus 1 electron becomes a neutral. Neutral here, neutral here. This one is balanced. Now, write the second equation. I minus, IO3 minus. Start 1I, 1I. I is balanced. 3O, no O on the side, so plus 3H2O. Now, 3 times 2, 6. So you add on this side 6 H pluses. Now the time to count the charges. 1 minus and 6 plus, that's a 5 plus. Here, only 1 minus. So, who's the side that has higher charge? This side. I need to drop من 5 plus 2 minus 1. So, 1 electron, 2 electrons, 3 electrons. You keep on adding electrons until if you added 5 electrons, you reach 0. If you added 6 electrons, you reach minus 1. So we add 6 electrons on the side that is higher. Now, we need to add these two half equations to get the final equation. So here I have 6 electrons and here 1. So I multiply this side by 6 to have it 6 electrons gained versus 6 electrons lost. And you add the two half equations. So 6, I'm going to write it here because no space. 6NO3 minus and 12H plus and I minus from here and 3H2O giving 6NO2, 6H2O, IO3 minus and 6H plus. Okay, yeah. Now 12H plus and 6H plus, 6H plus will remain here. Three H2O and 6H2O, 3 will remain on this side. So 6NO2, 3H2O, and IO3 minus. So this answer should be in A. So I'm gonna erase and write it in A because I need the space down. So the answer in part A is 6NO3 minus, don't forget the physical states, plus 6H plus I minus gives 6NO2 gas and 3H2O liquid and IO3 negative AQ. Now, that's it. We're done with part A. What is needed to balance in basic medium? In basic medium, we do exactly the same. There's just one more step to do. بنشوف, we look how many H plus we have. We have 6 H plus. So we add as much, يعني I have 6, I add 6 OH minus here and 6 OH minus there on both sides. And then you recopy the equation. And instead of 6H plus and 6OH minus, you will write 6H2O. So here, 6NO3 minus AQ plus 6H2O plus I minus gives 6NO2 gas and 3H2O and IO3 minus and the 6OH minus. And then 3H2O and 6H2O here, 3 will remain. يعني I will just place 3 instead of 6 and I'm done. I balanced it in the basic medium. Now, how many hydrogen ions are needed to balance the redox reaction? Here they don't want you to balance it. They already did the balancing, but they're hiding how many H plus I need to add over here. Look, how many H you have here? 14. So 14 H plus, you're done. Finish. You want to double check your work? Count the charges. 6 plus and 6 plus, how much is that? 12 plus. Here, 2 minus and 14 plus, 12 plus. I'm right. What is needed to balance it in basic medium? Okay, in basic medium, I need to look how many H plus I have. I have 14. So I'm gonna add to the 14 H plus 14 OH minus and copy the rest. Cr2O7 2 minus plus 3 Ni. And on the other side, I am also going to add 14 OH minus. This is how we balance in basic medium. So your answer will be, I need to add 14 OH minus to the side of reactants and to the side of products. If they ask you to continue, you continue. So instead of those, I am going to write it 14 H2O plus Cr2O7 2 minus plus 3 Ni gives 3 Ni2 plus 2 Cr3 plus 7 H2O and 14 OH minus. 7 and 14, you erase the 7 from the product, and this 14, you change it to 7. You're done. Given the following redox equation. Okay, this question came in last year end of term 2 exam. So I don't know if they're gonna give the same or change it. Write the reduction. Reduction. Let me check. I will check the easy one. I don't have to complicate things. This is 0. This turned plus a 3. So oxidation number increased. This is oxidation. So Fe solid to Fe 3 plus goes in here. It means that MnO4 minus goes in here. Let's start balancing. Here we go. 1 Mn, 1 Mn. Mn is good. 4O, no O. So I'm gonna add 4H2O on this side. By adding 4H2O, now I have 8 H's. So 8H plus. Now, charges 2 plus. And here, 8 and minus 1 means 7 plus. Where is the higher side? Here. 7, I will add 5 electrons so that the 7 can drop to 2. Done. That's it. You're done. Next, Fe, 1 Fe, 1 Fe. There's nothing to balance, only the charge. 3 plus, 3 electrons. Sorry, 3 electrons. Now, write the overall. Overall. Good. The overall, it means this one and this one. You see here the 5? you multiply this one by 5. And the 3 here, you multiply this one by 3. And you copy them again. 3 MnO4. Why? Because I need the number of electrons lost and gained to be equal. Okay. Now, 3 MnO4 plus 8 times 3, that's a 24, plus 5 Fe solid AQ. Don't forget the physical state. There are marks on the physical state. 3 Mn2 plus 3 times 4, 12 H2O, 5 Fe, 3 plus. Next. Definitions. Definitions will come in multiple choice questions. So we need to memorize the definitions. Electrical current. If you forgot, look at the formula sheet. There is, in the formula sheet, they are telling you what means, what does volt mean, voltage mean. And it is, I'm just trying to check on the formula sheet, where can you find it? Standard. On the, I don't know, I can't find it. Oh, yes. It's in the AP chemistry, the first page of the formula sheet, page 4 in the document I shared. There are table of units. You will find the unit of volt. Okay? And you will find the unit of ampere. If you forgot what's the definition of electrical current, use the formula. Use the unit. Okay? So, electric current is the flow of electric charges. It's the coulombs. The coulombs per second. The electric current, it's the coulomb per second. So just use the word flow. It's the charges flowing. Okay, so here in the answer key we mentioned, since redox reaction involves the transfer of electrons from one substance to another, once electrons are transferred, this transfer of electron and migration of ions from electrode to electrode creates, as a result, it creates a flow of charges. It creates a current in ampere. Oxidation half reactions, it's the half reaction that involves loss of electrons. Reduction half reactions, it's the half reaction that involves gain of electrons. Oxidizing agent. Oxidizing agent is the reactant that undergoes a reduction, gain electrons. But it allows the other substance to get oxidized. That's why we call it oxidizing agent. So itself, it gets reduced, but it affects the other substance to get oxidized. Reducing agent, for itself, that substance will undergoes an oxidation and allows the other substance to get reduced. Redox reaction is an overall reaction that involves a half oxidation and half reduction equation. It's a reaction that occurs when between substances exchanging, transferring electrons. One loses, one gains. Next, the difference between voltaic electrolytic cell. We did both of them. Electrolytic cell is a non-spontaneous cell. It's a cell that has the voltage negative. It's the cell that requires a battery, requires an electric current to start, to produce a chemical reaction. This is the reaction, this is the cell that delta G is positive. This is the cell that has K less than 1. Voltaic is the spontaneous galvanic cell. This is the cell that has positive voltage. This is the cell that, due to a chemical reaction, an electric current is produced. So this is the one that produces an electric current as a result of a chemical reaction, this is the cell that has a negative delta G and a standard, and the K is above 1. Also called galvanic. Okay, now more differences. In the voltaic cell, this is where the anode is the negative electrode, and this is where the oxidation occurs. And the cathode is the positive electrode where reduction occurs. For the electrolytic cell, not much changes. Anode, the only change is that anode now is the positive electrode, but this is where the oxidation occurs. And cathode is the negative electrode where reduction occurs. Okay, so electrons always move from anode to cathode, current from cathode to anode. Same thing here, anode to cathode, electrons, cathode to anode, current. So that's it. Again, here, this is the same thing. You have to go back to the apparatus that we did in the lab and memorize all the parts. I'm gonna draw again a voltaic cell. A voltaic cell requires 2 solutions. 1 compartment, 1/2 cell, we consider it cathode, 1/2 cell, we consider it the anode. Now, let's say I have a copper electrode, the solution will be copper solution, like for example, copper sulfate. The electrode is zinc, it will be immersed in a zinc solution, مثلا zinc sulfate. Now, these 2 electrodes are connected to a voltmeter through electrical wires to facilitate the transfer of electrons. But at the same time, the cells are connected by a salt bridge. Salt bridge in the cell is very important. It allows the passage of ions between the 2 half cells, the anode and the electrode and the cathode, to maintain the cell neutrality. Why? Because in the cathode, we have reduction. We have the Cu2 plus reducing to Cu. So we have consumption of positive pluses. So the salt bridge will send the positive ions to this side to make the balance. And in this one, I have here, let's say the anode, where I have an oxidation, zinc is turning into Zn2 plus. So I have more production of positive ions. So what will the salt bridge do? It will send to it the negative ions of that salt bridge to balance those pluses that appeared over here to keep the cell neutral. In the SBQ, I gave you once a question and I said, if a salt bridge is replaced with a metal, what happens to the cell? The cell will not work. Yani E cell will be 0. It will not operate, as if you removed that salt bridge. Yani you removed the salt bridge and you put a metal. Yani you didn't put what it needs. So the voltage will be 0. It will not operate. Of course, in the answer key, there are more. Maybe I missed something, but there will be more details. Yeah. I forgot. In the cathode, this is the one that gain electron, and this is the one that the electrode will gain mass, will become higher in mass. And in the anode, this is the electrode that is losing electrons, and the mass, this part will be lost. The mass will be decreasing. You will get questions in the exam where they will ask you to draw on the graph the direction of the ions. So remember this, cathode is the positive electrode, and in the salt bridge the pluses will migrate towards it. Anode is the negative electrode, and from the salt bridge the negative ions will migrate to it. So, and if they asked you to indicate on the, like last year, they gave the students a question to draw the sign of the direction of electrons. Please let your answer be clear. So you can do on the wire like this, migration of electron, or you can do like this, electrons moving. So in the voltaic cell, electrons flow from anode to cathode. And in a voltaic cell, current flow from cathode to anode. Direction of ions in the salt bridge. Here's the salt bridge. The positive ions of the salt bridge will migrate toward the cathode. And the negative ions, no, wait 1 second. Yes, true. And the negative ions will migrate toward the anode. Here, I did it in the opposite way, but it's correct. To maintain the cell neutrality. Explain the cell notation. Okay, I erased that cell notation because I was erasing the answer, so I'm gonna write it again. That is the cell notation given to you in the questions. Okay, this is a salt bridge represented by 2 lines. Whatever is written here represents what's happening at the anode. And at the anode, zinc turning to Zn2 plus 2 electrons. Whatever that is written over here, it is the cathode, and that's what's happening at the cathode level. It is the Cu2 plus gaining electrons, going and forming more copper solid. Don't forget the physical states. Next, consider, that's the question that came, I think, or maybe the previous year. Anyway, check the previous exams. They always bring questions from previous exams, nothing new. Identify the anode. From the given values, this requires less energy. So this is gonna play the role of a cathode, and therefore you choose the solid, not the one with ions, the solid. Zn is the cathode. Okay, they asked about the anode. Then SCr is the anode. Don't write Cr2 plus. If you write Cr2 plus, 0, you don't get the mark. You should write Cr. Please, these questions, repeat the question and double check your answer twice. Because if you select the wrong anode, A, B, C, D, everything will be wrong, and there is no error carried forward. They don't give you here the luxury of error carried forward. So you have to be careful in these questions. What happens to the masses of anode and masses of cathode? Anode, lose electron, lose mass. So mass decrease at the anode. Cathode, reduction, gain electron, gain mass. Mass will increase at the cathode. Write the balanced. So here, this is reduction. This is going to be oxidation. So what you will do here, this plus this, so Zn2 plus Cr solid gives this one and this one. Zinc solid and Cr2 plus aqueous. It's already balanced. 2 electrons gained, 2 electrons lost. On the diagram below, indicate the electron. How do they flow? They flow from anode to cathode. Don't just put a random arrow. You see this current, this electric wire, write E next to it. That's it. It means that the electrons are migrating in this direction. The salt bridge is filled with 1 molar KCl, يعني K plus and Cl minus. Where will the Cl minus go? It will go towards the anode. Where the K plus will go, it will go toward the positive electrode, the cathode. So Cl towards the anode, Cr. يعني like this. Cl minus, Cl minus, Cl minus, Cl minus. It's going like that. K plus going in this direction. K plus, K plus, K plus, K plus. Let it be clear your answer. Now, next, identify the sign. Okay, use the volta Excel in question 27 to calculate E cell. Identifying, okay, the favorability. This is a galvanic cell, so it is favored. I expect E cell to be positive. E cell, E cathode minus E anode. E cathode, cathode minus 0.76 minus E anode, which is negative 0.91. The answer will be positive 0.15 volt. Don't forget the unit. So, E cell positive, delta G, negative K over 1, favored. Which sign of E cell indicates a thermodynamically favored reaction? A positive sign of E cell. Explain how E cell is calculated. It's calculated through this formula. Which of the following is the reference electrode, the hydrogen. Reference electrode used to determine the standard electrode potentials. It's memorize the name. Standard hydrogen electrode, What's the standard electrode potential of the standard hydrogen electrode? Yes, it is 0. It is 0 volt. Now, write the half reactions. So this standard hydrogen electrode can undergo a reduction and can undergo an oxidation. So, it is if it's undergoing a reduction, it is H plus 2 electrons giving hydrogen gas. If it's undergoing an oxidation, it's the opposite. You flip it. Hydrogen gas, 2H plus 8U, don't forget, and I keep on forgetting it, plus 2 electrons. This is anode, this is cathode. Next, write the cell notation for a galvanic cell. Write the cell notation of a galvanic cell where the standard hydrogen electrode is the anode. Okay, so here's the anode. They told me that the hydrogen electrode is the anode. يعني it is undergoing an oxidation. يعني H2 to H plus. So it is H2 gas / H plus. Wait a minute. I cannot have an electrode from a gas. Therefore, I need to couple it with platinum wire. Usually, in the notation, if I have hydrogen gas, I may write next to it that this is a gas at 1 atmosphere. Optional to write 1 atmosphere. I can write it and I can just leave it as it is. Salt bridge. And then cathode is the copper. That's it. Consider the notation below. Okay. Zinc turning to zinc 2 plus, that's the anode. And H plus giving hydrogen, that's the cathode. The left side represents the anode where oxidation occurs. And the left side, the right side, that's wrong. The right side represents the cathode where reduction occurs. The double lines is the salt bridge. Write the reaction at the anode. Zn 2Zn2 plus 2 electrons AQ solid. Write the reaction of the cathode, this giving this one. H plus giving H2. Don't forget the balance. 2 hydrogen, you write here 2 plus 2 electrons, that's gas, that's AQ. And so here I don't have the figure, but it's well explained in the answer key. Let's move on. What is the correct relationship between, expect a question like this, E cell, positive, spontaneous reaction, product favored. That's it. Again, here, E cell, K, delta G. E cell positive, K above 1, delta G negative. E cell negative, we're talking about electrolytic cell. Not favored, delta G positive, non-spontaneous. E cell 0, K will be 1, delta G will be 0, we are at equilibrium. We're not spontaneous, we're not non-spontaneous, we're just at equilibrium. Next, write the equation used to calculate E cell and delta G. It's in the formula sheet, no need to memorize anything. Delta G is minus NF E cell. And here Faraday constant, don't memorize it, it's in the formula sheet. N is the amount of electrons transferred. Write the equation used to calculate E cell from K. Okay, so this one you have to memorize it. And I realized that I didn't memorize it. It's 0.050592. If I'm not mistaken, let me double check my notes. Okay, 1 second. 0.0592 log K over N. This is it. Do not use the other formula. This is the formula I taught you in class. Please use that one, because it's very easy to use it and more close to the real answer. Now, that's it. Calculate E if K is 10 to the power of 4. So log 1 times 10 to the power of 4 for the reaction of zinc. Okay, look, 2 plus, it means that each one of them lost 2 electrons. So here, divided by 2 electrons, and here's the value. We can get E in volt. And the answer will be 1084 volt. What defines a concentration cell? A concentration cell is a cell where the 2 half cells contain the same electrode for the same solution. Yani this is copper and this is copper. This is copper sulfate and this is copper sulfate, operating through a salt bridge and connected through wires. But what's so special about this concentration cell? How can I let it function? If the concentrations of these 2 cells are equal, like 1 molar, this cell is not going to give me a voltage. It will be 0. But how does it function? One has to be less than 1 molar, like for example 0.5 molar, and one has to be above 1 molar, 2 molar. The difference in the concentration will create a charge and move of electrons, migration of electrons, and a current. Okay, now which side will act as the anode? The one with less concentrations. يعني هلا in this example is going to be the anode where oxidation occurs. The one with lower concentration will be the anode. What is the voltage of the concentration cell when the ion concentrations are equal? Zero. It will not operate because there is no difference in the concentration of ions. How can it work? Why no current flow if the concentrations are equal? Flow what? What's gonna flow if the ions are same in both sides? The concentration of ions, yani the amount of ions on each side, the concentration of ions on each side is the same. So there's nothing to flow. However, if there's a difference in the concentration of ions, positive and or negative ions from both sides, then the ions will start flowing to balance each other. So we say that there is no driving force for electron flow. Why electron will flow if both sides are balanced? But if there is an imbalance, then electrons will start flowing. Which type of reaction are driven by electrolysis? Non-spontaneous reactions. Explain why an external energy source is needed for electrolysis. Because it's a non-spontaneous reaction, it needs an outside source like a voltage, like a battery, to initiate a chemical reaction. And you saw that when we did the experiment in class, I need a battery. Again, explain using diagrams the difference between voltaic and electrolytic cell. In the voltaic cell, I mentioned this before, for both of them. So voltaic, electrolytic. By the way, electrolytic, you have one compartment in which you have the electrodes immersed. In the voltaic, you have two different separated half cells with electrodes, salt bridge, connected through wires. Those are connected also through wires. Now, this is the anode, this is the cathode. Anode, cathode, oxidation, reduction. If this is negative, then this is the cathode. This is positive, this is the anode. Reduction and and oxidation. This is reduction, and here I have oxidation. Non-spontaneous, spontaneous. It does not require an outside source. It requires a battery, a voltage. It requires a battery. Here, when we put the substance that's gonna undergo an electrolysis, the positive ions of that substance will gather around the negative electrode, and the negative ions of that substance will gather around the positive electrode. Which cell contains a salt bridge? Only the voltaic. In both electrons, they flow in the same direction from anode to cathode. Which cell requires a battery? Electrolytic. Now, you will get a question like this in the exam. What are the products at the cathode and anode during electrolysis of molten KBr? So start thinking. Molten KBr means I have K plus and Br minus. K plus will go towards the So here's the electrode that is the cathode that is negative. K plus will be gathering around it. K plus at the cathode will give me K solid. So you answer at the cathode I have positive potassium, solid potassium. And here's the other electrode that is positive, the anode. Who will come? The Br minus will gather around it. The Br minus will change into Br2. So you will say at the anode I get Br2 liquid. Now predict the electrolysis of an ACl. Yalla, let me change it. An ACl. This is how it comes. Same thing. An ACl aqueous. Okay, in aqueous you have an A plus and you have the Cl minus and you have the H2O that is going to give me H2 and O2. So I need to check the voltages to see which one is going to win. Okay, now Na plus will come around here. Cl minus will come around here. At the anode, I have a competition between H2O that is going to give me oxygen and Cl minus that is going to give me Cl2. So I compare the voltages. According to the voltages, this will win. This requires less energy. So these will be given to you in a table. Now, at the cathode, I also have, other than Na plus that's going to convert to Na solid, I need to think about the H2O that is going to give me the hydrogen gas. Okay, so in here, the voltage of this one will win. So here we go. At the cathode, I'm not gonna get sodium plus. I'm gonna get the hydrogen gas. At the anode, I'm not gonna get oxygen. I am going to get the Cl2 gas. Okay, so in both of them, I am pumping the solution of dissolved aqueous, not molten, NaCl. It's going inside. It is providing me with the Na plus and the Cl minus, but as also I have the H2O. So that's what I get. So I'm plugging the solution. At the anode, I'll get the chlorine gas. At the cathode, I'll get the hydrogen gas. P is called the anode, and R is called the cathode. Write the oxidation reaction at the anode and the one at the cathode. So I said that Cl minus will win. So Cl minus will give me Cl2. 2Cl, start balancing the atoms of Cl. Now 2 minuses on this side, I'll add 2 electrons. You're done. That is at the positive electrode, the anode. Now, as I told you, at the cathode, I'm not gonna obtain sodium. I'm gonna get the hydrogen gas. So first of all, H2, H2. It is balanced. Now, to memorize this, OH minus, and I need to balance it, plus 2 electrons. That's it. That's at the cathode. Just memorize the equation at the electrolysis of water. You will know what to get. Again, molten KCl. This is anode positive. Let me change the color. This is the positive electrode. Who's gonna come next to it? The Cl minus. Cathode, this is the negative electrode. Who's gonna come next to it? The K plus. So, at the cathode, K plus will give me K solid plus 1 electron reduction. At the anode, I have the Cl minus giving me Cl2. Be careful, 2. So 2 Cl minus and 2 electron. Right? So what do they want? What is the product at anode? Cl2 liquid. And at cathode, potassium. It is solid, but here, Cl2, sorry, gas. Now, write the reaction. Okay, so you write this one here. K plus electron, K solid, Cl minus, giving Cl2, 2 electrons. And the overall, 2 electrons, 1 electron. So you multiply this by 2 and you get 2K plus AQ plus 2Cl minus AQ, giving 2K solid and Cl2 gas. So now magnesium, what are the products formed at the cathode and anode during the electrolysis of magnesium fluoride, MgF2? Cathode, again, is the negative electrode. Mg2 plus will come towards it. Mg2 plus will give me Mg solid. So at the cathode, I get solid magnesium. Anode is the positive electrode. F minus will come towards it. F minus will change into F2 plus 2 electrons. During electrolysis, again, molten sodium chloride. Definitely there's a question about electrolysis coming in the exam. So as I mentioned, at the cathode, I get sodium solid and the anode Cl2. During the electrolysis of KBr, K will be produced at the negative electrode, Br2 will be produced at the positive electrode. And that's it. What is galvanized iron nail? When an iron nail is coated with a thin layer of zinc to protect it against corrosion. So we're just coating the iron to protect it from corrosion. Identify different ways how the industry protect iron from rusting. Please memorize them. Coating with a metal that will form an oxide coat to protect a metal. Galvanizing, which means placing a sacrificial electrode instead of it that will get oxidized instead of the metal that we don't want to sacrifice it. Alloying, yani mixing the metal with a different metal to prevent it from oxidation. Or this is chemical way, physical way, oiling, covering it with oil, painting it, covering it with paints, or greasing. What are the 3 important components of rusting of iron? How can iron rust? We need oxygen from the atmosphere. We need the drops of water, yani the moisture, the humidity in the atmosphere, and we need electrolytes, charges. Name 3 methods used by industries to prevent iron from rusting. Please memorize that. You can alloy it, you can paint it, applying protective coating, galvanization, or using a sacrificial electrode. And that's it. Thank